In this video, we're going to illustrate how to conduct a non-parametric Wilcoxon t-test for paired samples using SPSS. And in this hypothetical study, here we see 10 research participants that were evaluated for reaction time, and this is measured in milliseconds, following the exposure to a particular signal on a computer screen. And we had one trial in which the signal flashed a red symbol, and a second trial that each participant participated in where the computer screen flashed a black signal. And these are measures along ratio values of milliseconds. So what we're going to demonstrate here is the way we can use SPSS to carry out the non-parametric paired approach, and then we'll compare it with the parametric approach to examining if there was a statistically significant difference between the two modes of stimulus in terms of the two color signals on reaction time. So I'm going to first do the non-parametric approach. And to do that, I'm going to click Analyze. I'm going to come down to Non-Parametric Tests. I'm going to go to Legacy Dialogues. Then I'm going to click Two Related Samples. And here is where I need to identify the variables in interest. So I want to bring over these two paired values. So I already have the reaction time in red highlighted. So I'm going to hold the Shift key down on my keyboard and click black. And then I'm going to pull these over. And that is the pair that we are comparing. We don't have a second pair, so we can just ignore that. Under Options, I'm just going to go ahead and click Descriptives to generate descriptive statistics. I'm going to continue. And there are a number of approaches here, but I'm going to zero in and focus on the Wilcoxon approach here to examining differences between these two measures. And I'm going to hit OK to run the analysis. And what we see here is we have a sample size of 10 for each of the two conditions because each of the 10 participants engaged in both trials. And what we see just based on the averages, the reaction time was longer when observing a black signal on a computer screen as opposed to a red signal on the computer screen. This was a lower value which indicated a faster reaction to that symbol. And we have the associated standard deviation values for both of those trials. And what we see here in the next table is the signed ranks table, where despite the fact that our original data are in ratio units, what the Wilcoxon approach does is it assigns ranks inside of those two individual conditions. The difference is then measured, and then the negative ranks is compared against the positive ranks. And so we see the lower value of the negative ranks is taken as the key Wilcoxon statistic. And in terms of the statistical significance, what we see here on the third table is that SPSS will take the lower of the ranked values, in this case it's the negative ranks, which outnumber the positive ranks, and converts that to a Z statistic along a Z distribution. And we can see here is that the negative ranks is indicated by the negative sign on the Z value of 2.310, and the critical value for Z at the 0.05 level is always 1.96 when we have a Z distribution. And so we see the associated p-value of 0.021, indicating that the probability of committing a type 1 error, the probability that we're making a mistake when we conclude that there is a statistically significant difference in reaction time, that risk is less than 5%. Specifically, that risk is 2.1% that we are making a mistake. So we would conclude here that there is a statistically significant difference in reaction time when viewing two different symbols on a computer screen where it takes longer to react with a black symbol than a red symbol. Now what I'm going to do now is I'm going to carry out the analysis once again. Since our original data are in ratio units, I'm going to go ahead and use the parametric equivalent, which is a paired samples t-test, and I'm just going to append those results to the bottom of this screen. So while I'm here in SPSS, I can go right to the Analyze, and I'm going to compare means and proportions, and I want the paired samples t-test. So in a similar way, I need to select my pairs. So I have red. I'm going to hold the Shift key down on my keyboard and click black. I'm going to pull those over. Once again, I'm just going to ignore the number 2. And in terms of the options in this case will allow us to establish a different confidence interval percentage, but the default is 95%, and I want to leave it there. So I'm going to continue, and the effect size is automatically checked, so I'm just going to leave that, and I hit OK. And under the t-test, what you see again here, the t-test approach will automatically generate descriptive statistics for the two different conditions, and we see a moderate to very moderate to strong correlation of 0.529, and in a paired comparison this is actually ideal. This is what we want to see. We want to see at least a moderate correlation. And so when we go down to the paired differences, what we're looking for is that calculated t-value of negative 2.954 with a degree of freedom of 9. And so here we see slightly different statistics. For the two-sided p is 0.016, and this is a smaller value than, let me just scroll up here, than the 0.021 on the non-parametric approach. So what we see here is that even when we take a parametric approach, we can conclude that there is a statistically significant difference in reaction time when viewing two different colored symbols on a computer screen, where the black symbol generated a longer time to the reaction than a distinctive red signal. So this ends this video on using SPSS to carry out paired comparisons.